Hello guys, I welcome you all to the lecture 4 of this introductory course on C++, where we are going to talk about bitwise operators. Okay, so before getting into bitwise operators, we must know uh, what are the bitwise representations that we commonly deal with while we are working with the numbers in C and C++. Okay, so in C++, we mostly deal with either the 32-bit numbers, okay, or 64-bit numbers at max. Okay, 64-bit numbers. Okay, so when we declare and initialize a number, let's say int a is equals to 5, so this represents that it is a 32-bit number. Okay, 32-bit number. So there are a range of numbers which comes under 32-bit, and there are a range of numbers which comes under 64-bit. Okay, so 64-bit numbers are usually larger than the 32-bit numbers. Okay, now what is meant by this 32-bit and what is meant by this 64-bit? So in 32-bit numbers, how we represent them? Okay, so assume that there are 32 places like this. Okay, there are 32 spaces. Okay, and each space can be filled with either 0 or 1. Okay, this is why it is called binary matlab we can we can either fill a space with 0 or we can fill it with 1. Okay, so each space can be filled with either 0 or 1. Okay, except the right leftmost space. Okay, so these there will be 32 spaces and each space can be filled with 1 or 0. Okay, and this the leftmost space, it signifies the sign. Okay, the sign of the number. So signifies the sign. Okay, so if we talk about unsigned integers, okay, unsigned integers, so there is something called unsigned integers. Okay, we haven't talked about them in the data type section, but I'll tell you right now. Okay, so an unsigned integer is represented like this: unsigned int. Okay, a is equals to 5. So this is a 32-bit integer, unsigned integer. Now a 32-bit unsigned integer has a range from 0 to 2 raised to power 32 minus 1. Okay, so this is the range of a 32-bit unsigned integer, whereas a 32-bit signed integer, okay, integer has a range from minus 2 raised to power 31 to 2 raised to power 31 minus 1. Okay, so this is the range for a 32-bit signed integer and this is the range for a 32-bit unsigned integer. Range means that the number will lie in between these two left and rightmost value. Okay, and it will include these two values as well, and 32-bit signed integer will lie in between these two values and it will also contain these two values. Okay, so this is like you know this way you can write this. Okay, sorry, let me write it again. So you can write it in the form of interval as well, if you know what I'm talking about, if you are familiar with maths. Okay, you can write them this way. Okay, 2 raised to power 31 minus 1 for the 32-bit signed integer, and for 32-bit unsigned integer you can write it this way. So 0 to 2 raised to power 32 minus 1. Okay, you can write them this way. This implies that left and right values are also included. Okay, these big brackets. Okay, so now you know about the 32-bit representation. So let's say we represent a number in the 32-bit representation. Okay, let's say we declared a number int a is equals to 5 in the program, in the C++ program. Now we want to write its 32-bit representation. So what happens is there will be 32 spaces. Okay, but 5 can be written as uh, you know so I forgot to tell you one thing. So bit magic or bit manipulation says that there is an idea of bit manipulation. So it says that any number, any mathematical number, okay, let be it 21, be it a prime number, be it a even number, okay, and odd number. So every number can be written as the sum of power of 2, either the sum of power of 2 okay, or it can be written as the power of 2 simply, okay, either this or this, okay. So let's check, okay. So 3, which is an odd number, okay, can be written as 2 raised to power 1 plus 2 raised to power 0. So 2 raised to power 1 is 2 only, and 2 raised to power 0 is 1, so it becomes 3, right? So it can 3 can be written as the sum of power of 2, okay. Now talking about an even number, let's say we take as 4, okay, we take 4 as the number. So 4 can be written as 2 raised to power 2, which is the sum of, which is the power of 2 only, not the sum of power of 2 but power of 2, okay. So let's take a prime number as well. So 7 is a prime number, right? So we can write it as 2 raised to power 2 plus 2 raised to power 1 plus 2 raised to power 0. So 2 raised to power 2 is 4 plus 2 raised to power 1 is 2 plus 2 raised to power 0 is 1. So it gives 7, okay. So any number can be written as either the sum of power of 2 or it can be written as the power of 2, okay. So how we represent them in the binary representation? So let's say we have 32 places, okay. So what happens is from the rightmost place we start counting, okay. So this is the first bit, okay, this is the second bit, okay, this is the first bit, this is the second bit, okay. Moving on to the last, which is going to be 32nd bit, okay, 32nd bit. So in the first place, if the value is 1, then this signifies 2 raised to power 0, okay. In the second place, if the value is 1, then this signifies 2 raised to power 1, okay. We do not have to consider the place, rather we will start with 0 from the first bit at the rightmost position, and then the second bit goes with the power of 1, okay. Third bit, if this place is 1, then it represents 2 raised to power 2, okay. Fourth bit, if this is 1, it represents 2 raised to power 3, okay. Let's move on to the next page, okay. Now similarly, let's say we have 32 bit, okay, 32 spaces, okay. I already told you that this leftmost bit will signify sign of the number, okay. Sign means plus or minus, whether the number is a positive number or whether it is a negative number, okay. So let's say this is the bitwise representation or bit representation of a particular number. So how the number can be written, okay. So this represents 2 raised to power 0. I already told you this is not set, okay. So if the place is filled with 0, then this is not set and we do not have to consider these places, okay. We only have to consider the places where the value is 1. So this is also 1, so we'll consider. So 2 raised to power 0, then this place would have been 2 raised to power 1, but it is not set, so we'll not consider it. This place is set, so we'll consider it, and hence it becomes 2 raised to power 0, 2 raised to power 1 and 2 raised to power 2. So now we can write this number, this bit representation as the sum of 2 raised to power 2 plus 2 raised to power 0. So it becomes 2 raised to power 2 is 4 plus 2 raised to power 0 is 1, okay. So it is 5. So this is a bitwise representation of 5, okay. If you don't want to confuse yourself, you can simply ignore these extra bits, okay. You can just write it as this way, okay. And base is 2 because it is binary representation, right? So if you have ever heard of binary representation, we write it with base 2, okay. You can also ignore this base if you want, okay. You can just simply write it this way. So this represents 2 raised to power 0, okay. This is not set, the second bit is not set, okay, it is 0, so we won't consider it. The third bit is set, so we'll consider it again, and it becomes 2 raised to power 2 because this would have been 2 raised to power 1, okay, if it would have been set, okay. So yeah, so this is why 5 can be also written as 2 raised to power 2 plus 2 raised to power 0. The earlier definition that I told you, that any number can be written as the sum of power of 2, right? So 2 raised to power 2 is 4 and 2 raised to power 0 is 1, that is 5, okay. So it gives us 5. So yeah, that was the bit representation of a number, okay. Why we write it this way? Any number can be represented in their bit representation. Let's say this is a representation given to us, okay, and we need to find the number. So what will be the number? The number will be this bit represents 2 raised to power 0, this bit represents, this is set, okay, all the bits are set, so we are going to consider every bit, okay. This represents 2 raised to power 1 and this final bit represents 2 raised to power 2, okay. This won't represent sign, okay, do not confuse yourself. If there are 32 bits given, okay, then only you will consider the leftmost bit. If it is set, then it represents a sign, okay, and if it is not set, then also it represents a sign, okay. Here we have only 3 bits, okay, we are not dealing with 32 bits, we are only given 3 bits, so we'll consider only 3 bits. So all the bits are set, so we add all these numbers, okay. So 2 raised to power 2 is 4, 2 raised to power 1 is 2, and 2 raised to power 0 is 1, so it becomes 7, okay. Now let us find bitwise, let us convert from bitwise representation of some numbers to the original number, okay. Let me take you to the next page, okay. Let's see some examples, okay. So some examples on this one, okay. So let's say we are given this as bitwise representation, as a bit representation, and we have to find the original number. So how will we find original number? So this one represents 2 raised to power 0, and this is set, so we will consider it, okay. This is also set, so we will consider 2 raised to power 1, okay. This is not set, okay, this is not set, so we are not going to consider this. This is set again, so we'll write 2 raised to power 3, because this would have been 2 raised to power 2, right, if this would have been a set bit, okay. So now what number do we get? 2 raised to power 3 plus 2 raised to power 1 plus 2 raised to power 0. We will only consider the 2's powers in the set bit places, okay. This is set because this is 1, this is also 1, and this is also 1, so we'll consider all 3, okay, only these 3. This is not set, this is 0, so we won't consider this. Otherwise it would have been 2 raised to power 2, right? 2 raised to power 2 would have been added into this one, but it is not set. Since it is not set, so we won't consider this. So the number is 2 raised to power 3, which is 8, plus 2 raised to power 1, that is 2, plus 2 raised to power 0, that is 1, okay. So 11 is the number, okay. So this bitwise representation, this is the bitwise representation of number 11, okay. In the 11 is the decimal representation, so we write it this way, base 10, but no problem if you do not get this, okay, you can simply write it as 11, okay, 11. Now let's take another example. Let's say we are given this number, okay. So this number, so let's define the original number. So this will be 2 raised to power 0, this will be 2 raised to power 1, we won't consider this place, because this is also not set, okay. These two places are not set, so we won't consider them. Now this becomes 2 raised to power 4, okay. So what will be the number? The number will be 2 raised to power 4 plus 2 raised to power 1 plus 2 raised to power 0, okay. So it becomes 16 plus 2 plus 1, which is 19, okay. So 19 is the original number. So this is the binary representation of number 19, okay. Now let us take another example. Let's move this up, okay. So let's say we are given this number, okay. So this is not set, so we won't consider this. This is also not set, so we won't consider this. This is also not set, so we won't consider this. This place is also not set, so we won't consider this. Finally this place is set, so we'll consider this. So it becomes 0, 1, 2, 3 and 4, so the power is 4. So it gives 2 raised to power 4, which is equal to 16. So this is in the form of power of 2, right? Okay, so this is in the form of power of 2, because we have only single set bit, right? When here we were having multiple set bits, so this is the sum of power, okay, sum of power of 2, okay. So yeah, this is what I was talking about earlier, okay. Either you can represent a number as the sum of power of 2, or either you can represent it as power of 2 in the bit representation. So this was all about the bit representation. From the next lecture we'll be talking about the various bitwise operators in C++. That's it for the video.